Take a moment, breathe out. Let your eyes adjust to the scene on your screen. What you are looking at is not CGI. It is not a desert in Chile or Utah, color graded to look alien. This is reality, capturing photons that bounced off a surface an average of 140 million miles away from where you sit right now. We are looking at the surface of Mars, a world that is at once hauntingly familiar and utterly alien. Today, we aren't just glancing at a picture. We are going to step inside this image. We are going to use this incredible 4K resolution to perform a deep dive into the geology, the atmosphere, and the deep time history frozen into this silent landscape. This image is a crime scene, a history book, and a treasure map all rolled into one. The rover that took this image, a nuclear-powered geologist on wheels, has paused its journey to capture this mosaic. It's a moment frozen in time on a planet where time moves incredibly slowly. So, let's stand beside the rover and take in the view. Let's deconstruct the Martian wilderness. Let's cast our eyes down to the immediate foreground, right where the rover's wheels would be crunching along. The immediate impression is texture. It looks gritty. You can almost feel the crunch under your boots. This isn't soil, not in the earthly sense. On Earth, soil is alive, filled with organic matter, microbes, roots, and decay. This is regolith. It is pulverized rock, broken down over billions of years by meteorite impacts, thermal stress from extreme temperature swings, and the ceaseless scouring of the wind. Notice the color. We call it the red planet. But when you look closely at the ground truth, it's a spectrum. There are butterscotch tones, deep ochres, rusty oranges, and sometimes even hints of blue-gray in the exposed bedrock. The pervasive redness comes from iron oxide, rust. Mars is, quite literally, a rusting world. The surface dust is incredibly fine, like talcum powder, and it coats everything. It gets into every mechanical joint, every camera lens. Look closely at the pebbles strewn across the regolith. Some are angular, jagged shards of volcanic basalt that haven't moved far from where they fractured. Others look different. If you zoom in, do you see some that look rounded? Smooth? On Earth, smooth? Rounded pebbles mean one thing: flowing water. A river running for thousands of years, tumbling stones over one another until their sharp edges are worn away. Finding rounded pebbles like these in the immediate foreground of a Mars photo is smoking gun evidence that we're standing in a dried-up lake bed or river delta. We are looking at a graveyard of ancient water. Also, notice the way the dust accumulates behind small rocks, forming tiny wind shadows. These are miniature dunes. They tell us the prevailing wind direction in this exact spot. Even in a photograph, you can see the atmosphere in action, shaping the landscape grain by grain. Let's lift our gaze to the midground, to those outcrops of bedrock rising out of the sand. This is where the deep story of Mars is written. If you look at the larger rock formations, you will see distinct layering. These are sedimentary rocks. Just like the Grand Canyon on Earth, these layers were laid down over eons. In many of these Martian panoramas, the lower layers tell the story of a wet Mars. They were deposited in standing water, perhaps a massive crater lake that existed 3.5 billion years ago. The chemistry of these rocks, analyzed by the rover's onboard laboratories, often reveals clay minerals and sulfates, things that form in liquid water that is neutral, perhaps even drinkable. This is the Goldilocks era of Mars that scientists are so desperate to understand. A time when the climate was thicker, warmer, and wetter. A time when life could have started here. But as your eye moves higher up the rock formations, the story often changes. The layers might show signs of crossbedding, patterns created not by gentle lake water, but by wind-blown sand dunes that later solidified into rock. We are visually seeing the climate change of an entire planet trapped in stone. We are seeing the transition from a blue Mars to the arid, frozen desert we see today. Sometime around 3 billion years ago, Mars lost its magnetic field. The solar wind stripped away its thick atmosphere. The water evaporated into space or froze underground, and the planet died. These rocks in the midground are monuments to that catastrophe. They are currently being carved by aeolian erosion, wind erosion. The strange, sometimes eerie shapes of Martian rocks, often looking like abstract sculptures or balancing stones, are the result of sandblasting that has gone on for billions of years without interruption by rain or vegetation. Now, let's look to the distance, the horizon of Mars. Depending on where the rover is, you might see the towering rim of a massive impact crater in the far distance, perhaps 50 or 60 miles away. The scale is immense. Because Mars is smaller than Earth, the horizon curves away faster. Things that look close are often much further away than they appear. And hanging over it all is that sky. You can see the gradient. It's not a uniform color. Near the horizon, it's often a brighter, almost pinkish white, transitioning to a deeper butterscotch or salmon color overhead. Why isn't it black? Mars has a very thin atmosphere, about 1% as thick as Earth's at sea level. You might expect it to be dark, like the moon's sky. But that incredible, fine dust we saw on the ground is also suspended high in the atmosphere. On Earth, our nitrogen-oxygen atmosphere scatters blue light, giving us blue skies. On Mars, the suspended dust particles are just the right size to scatter the red and orange wavelengths of sunlight, giving the sky its characteristic hue. It's a deadly sky. Without a thick atmosphere or a magnetic field, the surface is bombarded by cosmic rays and solar radiation. That beautiful, serene-looking vista is incredibly hostile to life as we know it today. The silence of the image masks a radiation environment that would break down complex organic molecules in a short geological time frame, which is why rovers have to drill inside those mid-ground rocks to look for preserved biosignatures. Occasionally, in these high-resolution images, you might catch something else in the sky: wispy, high-altitude clouds. They are made of water ice crystals, or sometimes even carbon dioxide ice, dry ice. They are tenuous and thin, but they prove that Mars still has an active, albeit thin, water cycle. Before we conclude, we have to talk about the image itself. The fact that you are watching this on your screen is a technological miracle. This isn't a single snap from an iPhone. This panorama is a mosaic. The rover's head, the mast, contains sophisticated cameras, like Curiosity's Mastcam or Perseverance's Mastcam Z. To create this view, the rover had to stand perfectly still, sometimes for over an hour, rotating its mast and taking dozens, sometimes hundreds, of overlapping individual photos. These digital files were then stored in the rover's memory. When the timing was right, when Mars rotated so that the rover had a line of sight to Earth or to an orbiter passing overhead, these bits of data were blasted across the void via radio waves, millions of miles of vacuum. The signal is incredibly faint by the time it reaches Earth. It's picked up by the massive dishes of NASA's Deep Space Network in places like California, Spain, or Australia. The data is gathered, decoded, and then image specialists at places like the Jet Propulsion Laboratory painstakingly stitch these dozens of photos together. They have to color correct them to match what the human eye would see, blend the edges, and create the seamless gigapixel reality you are exploring right now. Every pixel on your screen traveled an interplanetary journey to get to your retina. As we take one last look across this magnificent, desolate landscape, try to cast your mind forward. Right now, the only eyes gazing upon this scene are the glass lenses of our robotic avatars. They are our scouts, pushing into the unknown, enduring the hardships of a frozen world so we can learn its secrets. But this view serves another purpose. It is reconnaissance. Someday, perhaps in 15 years, perhaps in 30, a similar view will be seen through the visor of a human helmet. Those boots we imagined earlier, crunching into the regolith, will be real. When the first humans stand on Mars, they will look out at a scene very much like this one. They will see the layers of history in the canyon walls. They will feel the crunch of basalt underfoot. They will look up at that salmon sky. Images like this, viewed in this kind of fidelity, are the bridge between our present reality on Earth and our future destiny as a multiplanetary species. It transforms Mars from a wandering red dot in the night sky into a place with geography, weather, history, and perhaps secrets of life waiting to be discovered under just a few inches of dust. Thank you for joining me on this deep dive into the Martian surface. Keep this image on your biggest screen, let the details soak in, and keep looking up. Please subscribe to our channel, more Martian updates, and thanks for watching.